What is the difference? Steady versus transient CFD simulations. Imagine trying to predict how a fluid flows in a pipe or around an object. Will the flow stay the same or change over time? That's where the difference between steady and transient simulations comes into play. In computational fluid dynamics, steady-state simulations assume that flow properties like velocity, pressure, and temperature do not change with time. It's like taking a snapshot of the flow at one moment and assuming it stays that way. This approach is useful when the system is stable and not affected by sudden changes. For example, if you want to find out the average flow in a water pipe that runs constantly, steady-state modeling gives quick, reliable results. It's less demanding on your computer and faster to run, making it perfect for initial design checks or when conditions are constant. Transient simulations, on the other hand, track how flow properties evolve over time. They solve the equation step by step, capturing the start-up, shutdown, or any oscillations in the flow. Think of it like watching a video instead of a photo. These simulations are essential when the system experiences changes, like a fan turning on or off, or when flow rates fluctuate. They are more demanding because they requiring more calculations and longer run times, but they give a detailed picture of how the flow behaves during these changes. Choosing between the two depends on what you need to learn. If you want to understand the typical or final conditions of a stable system, steady-state simulations are your best choice. They are faster and simpler, giving you a good overview. But if you need to see how a system responds over time, such as during start-up or oscillations, transient simulations are necessary. They help you understand the dynamic behavior and are often used in designing systems that undergo frequent changes. In practice, engineers often run a steady-state simulation first. The results then serve as the starting point for a transient analysis, saving time and computational resources. This way, you get a quick overview and then a detailed look at the system's behavior when needed. To sum up, steady-state simulations assume no change over time, making them faster and easier. Transient simulations show how things change with time, providing a more detailed and realistic picture. Both are important tools in the field of computational fluid dynamics, helping engineers design better systems and analyze how they perform under different conditions.